So development of statistical process control. Let us go into the depth of this. Is a very important area. All of you type, please write in your notebook DMAIC, DMAC in your notes. Okay, DMAIC. For those who are here for the freshers, please write define, measure, analyze, improve and control. But here I put verify for a reason. Okay. Okay. Now define, measure, analyze, improve and control. So they use the DMAC process. There is also for the new product development, all of you please type DMADV, because these are all some important takeaways and learnings for today. Okay. I will ask you what is DMADV in the quiz. Okay. Okay. So DMAC stands for define, measure, analyze, improve and control. These are the 5 phases that is used to improve the process that already exists. A process that already exists uses which methodology, DMAC or DMADV? If I ask you, which answer will you give? Process which already exists, which methodology will you use? Okay. Then if I ask you, for developing a new process, which will you use? DMAIC or DMADV? Which is define, measure, analyze, design, and verify. Okay. These are all some background when you learn Six Sigma. These are all some important background that you should know. Okay. So we will talk about this DMAC in depth, and also we will go into the depth of DMADV. All right. Okay. Now, something very interesting. There was a person called as Carl Friedrich Gauss. Okay. All of you type GAUSS in the chat box. GAU. Very important person to remember. GAUSS. Guess who he is? Guess who is? Anybody knows who this Mr. Gauss is? It's also called Gaussian distribution. What is Gaussian distribution? Statistician, that's right. Normal curve is the right answer. Very good. So the Gaussian distribution is a normal distribution. So if you see the roots of statistical process control, this provides a backbone for the Six Sigma methods. And in 19th century, Mr. Gauss found out a distribution. Okay, it follows a particular pattern of distribution. It's called bell-shaped curve. All of you type bell in the chat box, BELL. Okay, or BSC in the chat box. BSC means bell-shaped curve. Okay, bell-shaped curve. Please write down on your notebook. I'm teaching you so fundamental, important things that you should remember. Okay, the curves looks something like this, a bell. Okay, so we call this as normal distribution, or it is also called as a Gaussian curve. Okay, and in most of the distribution, there are many distributions. You will learn about Poisson distribution, you will learn about binomial distribution, you will learn about chi-square distribution, Weibull distribution, and many other distributions. Okay, but this distribution is most widely used distribution. Okay, and many statistical tests are applicable only when it is in this sort of distribution, and you will later on learn that even if it is other distribution, people will transform to this normal distribution and then do the statistical test. Okay, so far if you're finding it interesting, useful, valuable, fantastic, awesome, just put it in the chat box. Let me also get some energy. Okay, thank you. Okay, let's move ahead. Okay. Okay, and another person, I'm going to introduce you to some of the statisticians, okay, because we are talking about all those who contributed to this statistical process control. So anybody who knows this gentleman, anybody who has seen this gentleman in any pictures, just type his name if you have seen this person. Elon Musk, no. Okay, Vijay is making fun now. Shewhart. Shewhart is the right answer. Okay, this is, we have spoken about the 19th century. In 20th century, there was this person called Walter Shewhart. Okay, all of you type WS in the chat box and also write in your notebooks this gentleman's name called Walter Shewhart. Good. So his contribution to the quality is many. Okay, but what stands out is a couple of things. Okay, so he was the one who related sigma level and quality. Sigma level and quality. He was the one who related sigma level and quality. And he was the father of control charts. Okay, father of control charts. Please write in your notebook FOC, father of control charts, FOCC. Okay, please write in your notebook. Because this is a sure question that would be asked. Who is considered to be the father of control charts? You must know this gentleman. Okay, superb. Okay, good. And also he was relating to the sigma level and quality. So with that, Walter Shewhart, let us also, if you see sigma level, some people might be wondering what sigma level. For those who wanted to access my previous videos, please join this upcoming webinar, and I will share this video with you once you come to my inner circle. Now, sigma level, I had shown you a table, okay? But what you have to understand from this table is, we had seen an Amazon example where if it is one sigma level of errors in invoices or orders, whatever, you would see that, 887200000 is the cost involved. Okay, and the defects, if you see 2539200, it exponentially drops. And if it is just if it is 6 sigma, it is just 3.4 defects per million opportunities, which is in Cyber Monday, the defects is only 125. And the cost is only $4,379. Okay, so all I want you to understand this. If you want to see this example, watch my previous videos. I've explained in depth. This is in chapter 1. But all that we need to see is 4 sigma and 3 sigma is over 78 million, and 5 sigma to 4 sigma is 7.6 million. Look at the difference between 78, almost 10 times reduction for 1 sigma level improvement. That is what you need to understand from this slide. Okay, so as much as it drops down drastically when you improve the sigma level, it also increases exponentially when your sigma level deteriorates. That is, if it goes from 3 sigma, if it drops to 2 sigma level, the error rates exponentially increases. So that is the essence of this slide. Okay, now we said Shewhart was the father of this control charts, right? Now, what is this control chart? These control charts are a statistical way of finding out how a process is behaving and ensuring that it is within some control limits. These control charts, don't get overwhelmed by this. I'm just introducing. The more importance is towards the person who actually contributed to 6 sigma and not what he has contributed. This control chart will be explained in depth in the control phase of 6 sigma. Okay, but then I'm just introducing this control chart overview just to acknowledge this gentleman called Walter Shewhart. Okay. Okay. So at the time when scholars were writing about theoretical application of statistics in growing number of fields, Shewhart was the one who developed to apply these concepts. There were a lot of mathematicians who were theoretically doing something, but Shewhart was the one who practically applied in the manufacturing and industrial process. Okay, and all of you, let us remember and pay tributes to Deming, D-E-M-I-N-G. All of you, type Deming. Okay, great. And these are very important things, even if you're from the examination point of view also. I'm going to show these pictures and ask, who is this gentleman? Okay, who is this guru, what he has contributed, and all that stuff. So during the same period, Edward Deming was working for US Department of Agriculture. Okay, he was a physicist, he was a mathematician, and he was in charge of teaching in a graduate school, in a school. And he and Mr. Shewhart became friends because they were mathematicians and they were very close. And he invited Walter Shewhart to come and speak in his school. And then Deming also took these concepts from Walter Shewhart, particularly all the statistical concepts like control charts and other things, sigma levels and things, and then he took to the entire world. So that was about Deming, and most important contribution by Deming was Deming's PDCA. All of you, please write in your notebooks, Deming's PDCA. In fact, Deming actually acknowledged Walter Shewhart for PDCA concept. He only popularized what Shewhart has done. Okay, actually PDCA was followed by, this concept was followed by Walter Shewhart. Okay, but then he made this framework all over the world, and they started calling it as Deming's PDCA. Okay. So plan is the improvement comes when you recognize there is a need for a change, and you have to plan for making the improvement, and then implement these improvements. Okay, and then verify, check whether it is as per plan, whether we are reaching the objectives or not, and then do the adjustment so that we can go towards the goal, we can go towards the objective. That is the essence of PDCA. Okay. In fact, this is the cycle of continuous improvement. The PDCA never ends. You need to continuously improve, and that is why PDCA followed by SDCA. PDCA followed by SDCA. SDCA means after you do the improvement plan, do check and adjust, and after you have done an improvement, standardize it, you sustain it. And after you standardize it, follow the standard, which is called standard, do, check, and act. All of you type SDCA in the chat box. SDCA, okay? PDCA followed by SDCA. And SDCA means you have to follow, this is very simple. For example, if I have to improve my health, if I am having a high sugar level, and if I want to improve my health, so what I first do is, I plan to reduce my sugar level. I implement a few practices. I check whether my sugar level has decreased or not. I make a relevant adjustment if I don't achieve the goals, and then make sure that I reach as per what my objective is, what I have planned and what my objective is. But then what is important is, once I have reduced my sugar level from 200 to probably 180, it is important that I sustain there and I follow some good practices, which is like, my eating habits, my health routines, and things like that. And those standards that I'll have to follow, implement those standards as being standardized so that my sugar level does not rise again. And then I should maintain that at 180 level or 170 level for some time, and then again go for a PDCA cycle to reduce it further, because the ideal sugar level is, I think, around 120. Okay, if this is clear, all of you type super clear in the chat box. I'm giving you a very simple example so that this PDCA cycle is applicable across all the. It's a very simple framework, but then when you actually look at the applications of this, everything comes under, every methodology comes under plan, do, check. Okay. For those who are not clear, because most of them are typed super clear, somebody said not clear, don't worry, watch these videos. Okay, go through the learning. It is just that you have to be determined to be focused and learn. You will understand. This is a very simple concept. Okay. Okay, now World War II. Anybody who remembers when the World War II happened? All of you type the year, World War II year. Let's see. Yeah. Great. Okay, so after the World War, the Japan was bombed. Okay, Japan was bombed, and they were really, in shackles, very disturbed. But then one thing we must recognize, the United States is the government actually requested Mr. Deming to visit Japan and help them to scale up their economy through this best quality practices. So Deming worked in Japan on behalf of the United States government in several capacities. Okay, you can see Mr. Deming, Mr. Juran, and all these people here. Okay, so he was also had a meeting with Ishikawa. Okay, Ishikawa. How many of you have heard about Ishikawa? Just tell me what Ishikawa has actually given you to this world of lean fishbone diagram. Very good. Cause and effect diagram. It's called as an Ishikawa diagram. Okay, fantastic. Super. Okay. Okay. Imani is very more bothered whether it is a live session. Please focus on the session. Okay, that's more important. Okay. So Ishikawa and all these quality gurus are here. So Deming went there. Deming actually befriended a lot of statisticians, convinced them, to use the statistical process control so that they can quickly revive the Japanese economy post World War II. And his methodologies, his framework. Okay. Also, if you follow that framework, there is also an award called Deming Award. Okay. So he became such a valued teacher, and people wanted to follow his framework. And under his framework was initiated a model called as a Deming Model of Excellence. And under this model, many companies are evaluated and they are given a award. It was called as a Deming Award. Okay. So far, if you're finding it interesting, useful, valuable, fantastic, awesome, please put it in the chat box. Let us go further. Okay. Today is amazing. 900 plus people still there. Nice. Okay. So the question here. Okay. Question here. How many of you are ready for question? Just type ready in the chat box. Super ready. Okay. Who is considered as father of control charts? I'm not going to give the answers. Who is considered to be the father of control? Somebody is typing Deming. Okay. Okay. A is Juran. B is Edward Deming. C is Walter Shewhart. D is Taiichi Ohno. So what is your answer? All right. So answers are pouring in. That is the Walter Shewhart. Fantastic. Super. And this is a picture of Walter Shewhart. I'm showing Walter Shewhart picture photograph because there is also a question where I'll ask, share the picture and ask, who is this gentleman who is considered to be father of control charts, or name this gentleman, what he has contributed, etc., etc. A lot of questions related to this. Okay. Now, continuous improvement, process improvement, Toyota, production systems, and lean. Okay. So many people played a big role. Now that we have talked about the quality movements, quality gurus, now we are going to introduce this lean and Six Sigma type of gurus. Okay. So lean's objective is to do it faster. Okay. And be more efficient. Okay. So who is this gentleman? Okay. Deming. Again, when we talk about even Toyota production system, we cannot, forget Mr. Deming, because he was the one who succeeded to help. He was the one who helped Japan to succeed to recover from the devastating war. So before the World War II, actually Toyota leaders talk about making things good. Okay, they were just talking about making things good, but after that they realized it was really important to make things better, more efficient, because Japan did not have a lot of money and materials. So they really wanted to be lean, okay, because they were deprived of a lot of resources. So they wanted to be maximum efficient with lowest resources. How to achieve maximum is what the order of the day. Okay. Now, I'm not going to ask you who this gentleman is. I'm sure most of you know him. His name is Henry Ford. So in fact, Toyota got ideas from Henry Ford. Okay. And they built on their ideas to create their own system. They use statistics, new quality concepts to increase production, because the mass production from Henry Ford is something, the economies of the scale helped them, and then later on they converted mass production, because first it was only craftsmanship type of production where individual parts were made, and it was not made in volumes. But then Henry Ford was the one who made interchangeable parts, repeated processes, and he was very successful in mass production. And Japanese borrowed these ideas, but later on converted the lean, because it was not a seller's market, it was a buyer's market. When Henry Ford introduced, he said, I can sell you any color car as long as it is, fill up the blanks. Let's see, anybody knows this famous quote. I can give you any color car as long as it is black, right? Okay, because it was the seller's market. So he was able to push whatever that he has made. But then later on, when customers started demanding different colors, different varieties, and this thing like that, mass production could not help. And hence the ideas of Toyota, which we are going to do in later chapters, that the lean production becomes very, very handy. Okay, so time for question and answers. How many of you are ready for quiz? Just type ready in the chat box. Okay, great. Okay, the question is, the guru who first helped Japan in quality movement or recover Japanese from the devastating war, recover Japanese economy from a devastating war, is Joseph Juran, Edward Deming, Walter Shewhart, or Taichi Ono? Yes. Salutations to Dr. Edward Deming. Okay. So the correct answer is Edward Deming. I hope today's session you found it interesting, valuable, useful, fantastic, awesome, whatever that you felt. Please share in the chat box.